This is a recording where I'm going to attempt Quest 18. I haven't opened it yet. I have no idea what's in there. So I guess if you're already watching this recording, you know how long it took me by how long the video is. Hopefully I'm not going to embarrass myself here in a moment. However, before I go ahead and open Quest 18 of Everybody Codes, I'm going to set up a skeleton file here. Unlike when I did Quest 17, I'm going to remember to change my input file names, because that was a mistake. Okay, so we're going to do problem 1, then problem 2, then problem 3, and we're going to use Quest 18 each time. 18, 18, 18, and I don't know if I'll need that or not. And do problem 1 is just going to be unimplemented. Okay. Okay, and do problem 2 is going to do the same thing. Two, 3. Okay, we are doing Quest 18 each time. Yep. Okay, let's go open it up. Everybody Codes. Okay, here we go. 18. Part 1. Near the rapidly rapidly constructed shrine of the god Null Pointer, which we did in a previous quest that I can't remember if it was one of the quests that I did offline or a recording of. The new area is being allocated for palm tree cultivation. It's quite suitable for these plants. Challenging. Irrigation system is a network of channels. Oh god, another map. Network of channels that will continue to supply. There are concerns about the distance over which an adequate amount of water. Some may evaporate the stream so quickly that the water disappears before reaching all the targets. The first palm farm is already in construction, but the Knights are still analyzing its design. Palm trees are marked with P, channels are marked with dot. Edge of the farm is exactly the edge, there's one. This is where water, every minute the water spreads out to all adjacent channel segments, vertically and horizontally, of course. The segments of the palm trees will be at the same level. Channel water can flow through them just like a regular channel segment. Calculate the time needed for water to reach all the palm trees from the moment the channel is supplied with water at the edge point. Okay, so 0. Okay, so at time 0 we have something already there. 0, 1, 2, 3, 4, 5. Okay. Okay, well, this should be straightforward. I mean, I know that I'm tempting fate by saying that. Yeah. But yeah, this is very similar to how I've approached a lot of these problems. So here we first do just the standard thing to scanner is equal to buffio.new scanner of bytes.new reader of data. Grid. Okay, what do I do? I'll make it yeah. make of byte 0 make that a map point bool, and now I don't have point in here yet, so let me add that. Type point struct int. Okay, and then for scanner.scan. So this is all pretty normal stuff. Row, actually, grid.append scanner.bytes. Yeah. Actually, what I'm going to have to do is I'm going to have to do this. Say row scanner.bytes. For call idx ch range row if ch is equal to p palm trees point length of grid call idx true for yeah call idx. Actually, I don't really need the locations of these palm trees, I just need the number of palm trees. But, oh well. Yeah, oh well. For call idx ch range row, ch is p, and then grid append row. Now, up here, func neighbors grid byte current point point return a list of point, and these will be and I'll just say sx equals current.x sy current.y. For rebel make point 0 or rebel for candidate underscore candidate in range point sx minus 1 sy Sx sy minus 1, Sx sy plus 1, Sx plus 1, Sy. For candidate is in those things, I'm going to just add the candidate to retval. So retval append candidate. Okay, and then let's see. Yeah. Q make. Okay, so what do I need for Q? I need a point and a distance. Yeah, I need both a point and except I don't actually. So to just make bin there be a map from point to int, make, and then I'll let Q be, oh wait, so if, yeah, okay, var start out point. Okay, we've got to find the spot on the edge where they're letting the water in. So else if call idx equals 0, if call idx equals len row minus 1, if then actually, and what I want to see here is ch equals dot and that, then start of is equal to okay, so Q is, so while, not while, still not while. Actually I'm going to say while palm trees have last list for when palm trees greater than 0, I'm just going to delete the palm tree as I see it. So current equals Q bracket Q bracket 0, Q equals Q1 colon if grid bracket current.x current.y, if it's a palm tree, then palm tree dist is equal to bin there of current. Also, oh, actually, I can just do this. I can just do, I don't even need to check the grid anymore. I mean, obviously, I need to check the grid for the neighbors, but yeah. What I can say here is I can say if palm trees, current, delete, palm trees, current. Okay, now for neighbors of the grid, oh, I need to change something here, obviously. Okay, up here I wanted to change something, so if Sx greater than or equal to 0 and Sx less than height, I know, x going up, down, y going across, whatever, it's row columns, whatever, and sy, oh, except I don't need this. I need candidate.x. Candidate.x greater than 0 and candidate.x less than height and candidate.y greater than or equal to 0 and candidate.y less than or equal to width. And then if grid bracket candidate.x candidate.y is not a bad thing, why is this not there? So if grid candidate x candidate y is not a bad thing, then sure, we have a neighbor. So for neighbors here in range, I'm going to say if been there neighbor continue. If okay, rain been there neighbor, continue. Otherwise, otherwise I'm going to say that is that all I need? Yeah. Otherwise, I'm going to say my dist plus 1, right? Otherwise, I'm going to say been there neighbor my dist plus 1 q dot append neighbor. And then what I'm going to do here is I'm just going to return strconv dot I to a of last palm tree dist. Okay, and that should be it. Quest 18 Part 1 in the bag. I mean, not really, because I have to, you know, run it. 101. 101, is that? Okay, well, I think that's reasonable, but we'll see what they say. Yay! Okay, second part. Water below side, 2 points on opposite side. Every time you use water flows. Times needed for water. All the palm trees on the second farm. Okay, so I'm going to see if I can put this into the same function by just doing this. Make append that, and then Q is slices dot clone start looks. Okay, so we do that, and I think this allows me to yeah, no, this allows me to work again. Oh, I gotta grab the input, grab the input file, because without it, nothing happens. Okay, what? Panic Endless Hour 00. Okay, part 1. Line 84. Okay, so let me just check what this looks like. Of course, I can't actually see that. Okay, so yeah, it looks like we're putting in water at both those ends. Huh. Okay, so we're putting water at like the top left and top right. Yeah, that's fine. Okay, so what's going on here? Okay, so Q ends up at 0, so okay. And yet we run out of palm trees. Okay, so do that. So we run out of places to put water, but not out of palm trees. What is going on? So we set that to my dest of been there, current, right? Okay, let me get the sample data. Okay. File, save as. Save. $21. And that is in fact exactly what it should be. 21. So the question is, why do we still have a palm tree if we don't have... Okay. So what I'm going to do here is do problem 1. So, well, for len palm trees is greater than 0 and len q greater than 0, if len palm trees greater than 0, then what we got to do is we got to print it out and we got to say everything where there is water. And I'll use, for a waterlogged palm tree, I'll use a W. Okay, so for row range grid for EX range len grid of 0, print. Okay, so I'm just going to print. So is equal to grid row call if bin there of ch. So this is not going to mean it's processed necessarily, but it means that we, yeah, bin there ch, then yeah, sorry, not point row call, then if ch is a p, we will set ch to a w, else ch tilde. Print ch. print line. Okay, so I don't want to do that anymore because that's not helping. Actually, I want to open a new tab. And I want to set the font kind of small. And I apologize if this is now an eye test for some of the people here reading it, but I don't know how else I'm going to print out the thing. Okay. Now let's see if we do it on the real input. Oh, duh. Okay, so here, print rune. What? Can we, what if we do string? Okay, and so we have water. Oh, wait, what are these? Okay, water. So this water ends up, does this water flow everywhere that it can flow? Yes. Does this water flow ever? What? Wait, are there all these things at the top? What's going on here, guys? There shouldn't be all those things at the top. Yeah, no, it's a solid line. Oh. But in any case, there shouldn't... Okay, I have obviously... row is range length of grid. Row... Okay, let me just print line okay, let's just do that. Oh. Okay, why are there all these dots on the first row? I mean, what happens if we do that? Now, there's all these dots here. Zero, one, two. And the first thing, okay, wait. Stuff is moving around in my grid. I don't understand. It's blocking off. Okay, so something really weird is happening here. Oh! Slices done. Okay. Okay, so here we can get rid of this. So my problem is that I was appending here row, but that depends on the return of scanner.bytes, and that may point at bytes that get overwritten. So that's the problem here. Oh, that's not the PowerShell I want. What is the PowerShell I want? That's the PowerShell I want. Okay, 804. Sorry about that, guys. Yeah. Last of the farms, the largest, doesn't have any entry points. Turns out there are groundwater reserves of land and they're under high pressure, so it's enough to dig a big well that occupies the entire segment with the optimal spot and let dig. Well should be dug at one of the channel segments arch with dot. Okay, so first off, we are not asking for the last one. Sum of the times that it takes for the water to reach all of the palm trees. Okay, but we've got to find the optimal spot. So what I'm going to do is I'm going to start at all of the palm trees, and I'm going to spill water backwards. And when I get to a spot that is reached by every palm tree, this will mean, though, that I have to. This will mean that I have to say that you can't. So bin there will be a combination of from this palm tree I got to this spot. Okay, I need a more complicated type for Q, so I might as well make bin there simple. Okay. So do problem 3 will be different. Although we will at least now be doing that. Okay, so do problem 3. Okay. Now, what we'll be doing is, now what do they want? They want the sum of the times it takes for the water to reach all the palm trees. Interesting, but okay. So we don't need start lokes. So there are no start lokes. Okay, so we start with all of the palm trees and 0, and then okay, so again, I'm going to do a basic work queue algorithm where I put stuff in a queue. I do a for loop while there's some condition unmet, although I'll probably just do a for true and then break this time. But anyway, I start with a queue and I do a for loop, and in the for loop, the first thing I do is I take something out of the queue and I set queue to 1 and the rest. So type queue type. So the question is, what do I want to readjust my mic? What do I want to keep in the queue? So queue type struct. So I have a point that I'm working from. I have a palm tree I came from. And then what I'm going to want is I'm going to want to know when I get to a spot where all the palm trees have dumped water on that spot. Palm start and dist int, and then bin there. Okay, and then type bin there type struct is going to be the key to bin there is going to be 2 spots. Spot point start. So bin there make map of bin there type to bool queue make queue type nothing in it yet for tree palm tree range palm trees queue bracket queue dot append queue type of a spot, spot tree 0. Okay, so I have that. And then also, and then I need a second bin there type, and I need I'll call it visited count. Make map point int. Okay, so visited count is going to be how often we actually hit that. For line queue greater than 0, although honestly here I'm going to break at some point, or actually I'll probably just return. So current is queue of 0, queue equals q1 colon. Then if bin there of bin there type bt key bin there type of current dot spot current dot palm start of bt key continue. Okay. BT key equals true. Visited count of current dot spot plus plus if visited count of current dot spot equals len palm trees if grid of current dot spot dot x current dot spot dot y dot. Okay, we have found our spot. Damn it. This. Okay, dist sum current dot spot current dot dist if return dist sum current dot spot. Yeah. You know what? Deal. Sometimes we return ints. Okay. And otherwise, yeah. Q.append. Okay, I need a neighbor spot, so a neighbor will be so it'll be Q type of now what do I have spot palm start. So neighbor current dot palm start current dot dist plus 1. Okay, and that should be it. That should let me flood. So I flood from palm trees out instead of, but that's okay. And then I do want the sum of And you do want the sum of the times for all the palm trees, which is a stupid measure. I think this should be the last palm tree as well. But whatever. Okay. Oh. Well, that's interesting. The queue ran out of things. Okay. So I started all the palm trees, right? And all the palm trees start with a different thing. I am cloning the row. And been there type is only happens if you've been there with that palm tree and visited count goes up by 1. Dist sum to get to the current spot goes up by 1. I don't see how... Oh! This is another one of those. I forgot to download the file and I forget to... Yeah. No! What? Okay, so I'm close, but I'm not there yet. Okay, so let's try this again, based on those notes. Okay, this file, save as. Okay, and quest 18. Okay, and say the amount. Oh! Interesting. Let's see. Right, because we are after the sum of times, and that's not what I'm finding. I'm finding the thing with the smallest, largest time. But that's not necessarily the thing with the smallest sum of times. Okay, so we're going to have to... we're going to have to not do this. We're going to have to say... good spot min sum dot max int, and then here we're going to say okay, and then this, yep, produces the correct answer on the sample now. It's taken a lot longer, but it produces a different answer there. And smaller. Yay! Okay, good. So I will close this out, and this is just under an hour. So this is a little slower than I would like. I may want to see if I can figure out some way to speed it up. I don't know about that though. But okay, so the problem was that we need the minimum of the sum of the distances, and the only way I know to do that is to just flood the entire thing and count all the, add up all of the sums, which is not great. There are probably also ways to avoid using quite so many hash lookups. Maybe by setting the palm trees to just an int. Actually, I could do that pretty easily. The palm starts I don't ever use anymore, so instead of palm start, what if I rename that to palm ID X, and that's an int, and this also becomes palm ID X, and that's an int, and then this are tree in range palm trees, so then I'll do IDX 0, IDX, IDX plus plus. Okay, so all we really need to capture is that you start at different palm trees. We don't care which palm tree it is. Now, of course, I should have been properly measuring that beforehand. So I think that sped it up, but I don't know. Oh wait, it's not 17 I want to build, it's 18 I want to build. Measure command 18. Yeah, 2.2 seconds. Okay, well, we can do better than that. So bin there count. So what if instead of bin there type we just had index from spot to spot and then palm, and they were all it was just a 3D map, 3D grid. So what if here we do bin there being that, bool. And we say for row IDX row IDX in range when grid for call idx range when grid 0 here what I want to say is I want to say bin there, actually bt row make bool 0, and then for call idx bt row dot append make bool okay, and then actually here we can just say poem count, and here we don't actually need the things, and then bt key doesn't exist, and instead what we say is if bin there bin there current spot x current spot y current.poem index continue, otherwise so one thing I've learned is that in Golang maps are actually kind of suspect in terms of performance. So these maps from points to ints, we can actually just do that. And then this will be, except that that's visit count row. Okay, these are just ints, and here we just want also I need in there append BT row, duh, and BC row is and yeah, this is DS row. And then DS row, and then instead of this we do visited count x y. And so all I'm doing here is I'm just replacing my replacing all those maps by multidimensional arrays. And you wouldn't think that would make a huge difference, right? But in Golang, it so does. Okay, now, do I have any maps left? I mean, I have a map of palm trees initially that I make, but who cares about that? Yeah, so assuming I didn't, like, break it, this should be much faster. Okay, well, I broke it. It's producing clearly totally wrong thing. But it's so fast. But so fast to the wrong answer. That's not good. Oh. Right, I'll bet you that's math.maxint. Okay, so I'm gonna change this to len just in case. I got a weird feeling about that. No. Okay, that didn't change it. Okay, so oh, well, that could change things. There. Right. You're going to give me the right answer? Was that the right answer? I can't remember. Yep, it was. Okay, so let's see if I made it faster. Remember before it was giving us the right answer in 2.225 seconds. Okay, so we're down to 0.8 seconds from 2.25. So yeah, eliminating that. It's still actually a lot, but you know what? I'm not gonna try to sit here and profile this. This video has gone on long enough already. That's good enough. Solved quest 18. So there you go.